Hello friends and welcome at my channel. Today I would like to talk to you about domains. There are three main situations where we're talking about domains. Well, actually we talk always, if we're considering functions, about domains. If you're dealing with polynomials or simple trigonometric functions, if it's like sine or cosine, you have no troubles. You can put all the values for x, everything is fine. But the situation is slightly different if you are dealing with roots, with logarithms, or with fractions where the denominator could be zero. So that's why let's consider three examples that I'm going to compute now, and we're gonna determine the corresponding domains. So first of all, example number one, we're talking about the function f of x, which is equal to 1 divided over 4 minus x squared, for example. So how could we determine the domain? Well, that means actually we're talking about all the values that we're allowed to put for x. So the question is otherwise, which values are we not allowed to put in for x? And the answer is we have to put the denominator equal to 0. So 4 minus x squared being equal to 0. This is a binomial formula. 4 is 2 squared. So we can write it as 2 minus x times 2 plus x equals to 0, which means x1 is equal to 2 and x2 is equal to minus 2. So those two values are not allowed. That means x is the realm of real values not having minus 2 nor 2. That's it. All right, pretty simple. That's case number one. So make sure the denominator is unequal to 0. What is case number two? This is the square root. So let's see, f of x is equal to, let's say, square root out of x minus x cubed. Well, this is a kind of chained function, so we have a chain rule if we would like to compute derivative of this function, but we're just only interested in domain so far here. That's why I'm looking for which x values this radicand would be bigger or equal than 0. And it's, well, I think it's helpful to just see the graph. So you can take x out. It's 1 minus x squared equals to 0. x1 is 0. x2 is minus 1. x3 would be 1. So what is the graph of the function under the square root of the radicand? Well, this is 0, this is minus 1, this is 1, and we're falling, as you can see, so minus, because of minus 1 in front of x cubed, so it looks like this. Alright, so that's the graph. And actually we want to be bigger or equal than 0. That's minus 1, that's 1. So that means x should be less or equal than minus 1. X should be bigger or equal than 1, but less or equal than plus 1. 0, but less or equal than plus 1. So that means we're writing it down. X from minus infinity to minus 1, we're taking minus 1, we're including it. And from 0, which is included, to plus 1, which is included as well. That's it. So you see, basically I have to make sure to understand I know what's happening with the square root, but I'm also dealing with the cubic function and I should, well, know what's going on. All right. And the third case is the logarithmical function. So let's see, f of x equal to a logarithm of, well, let's say 2 plus x divided over 2 minus x. All right, logarithm means to the base of e. It doesn't matter actually because we're only talking about the expression in the logarithm itself. It could be base of 2, 10, 16, whatever you want to have. So if you know, the logarithms are only defined for positive values. So we basically have to make sure that 2 plus x divided over 2 minus x is bigger than 0 on one hand. But on the other hand, we have for sure, just without looking at the inequality now, have to make sure that the denominator that we're handling isn't equal to 0, so that means 2 minus x shouldn't be equal to 0. So 100% x is unequal to 2. That's just that to start with. Okay, so you see, if the fraction is positive, that means basically that both numerator and denominator must have the same sign. So they are either both positive or either both negative. First case, let's have 2 plus x positive and 2 minus x positive as well. So this is a system of inequalities. Is it possible to fulfill them simultaneously? Let's see. That would be x bigger than minus 2, and that would be, if I bring x, that would be smaller than 2. X smaller than 2. So could I have it at the same time? Yes, I could. So this is minus 2. We don't have it, so it's not included. It's excluded. And this is 2. We don't have it either. We're going down. So they, as you see, they match at between minus 2 and 2. So the solution would be from minus 2 to 2. This is the domain, but we also have the second case. Put it here. So that means both are negative. 2 plus x is less than 0, and 2 minus x would be less than 0 as well. So what will happen here? That means x is less than minus 2, and x is bigger than 2. Is that possible? Well, we want to have it at the same time. Don't forget about that. So less than minus 2 means we're here, and bigger than 2 means we're there. Well, they never meet, so it's not working. So the whole domain is here, from minus 2 to 2. That's it. I hope it was clear what I was doing. Maybe I'll do one more video about domains next time, but you see clearly we have to understand what is happening with functions, and these are three most important cases. Maybe in the next video we will see another one, logarithmical example with rather more complicated fraction inside it, but the main ideas are in those three examples perfectly clear. Okay, thanks for watching and see you in the next videos, guys. Bye bye.